And now we will proceed with Estonian Land Board representative Hendrik Pungar. And he will tell a story about GIS analysis in land mass appraisal of Estonia. Welcome, stage is yours.
So thank you for this wonderful introduction. Greetings to all. I hope you're doing well. My name is Hendrik. I am a data analyst at the Estonian Land Board, and I'm here today to talk to you about GIS analysis in landmass appraisal of Estonia. So firstly, just a brief, quick introduction into what the mass valuation project was. So this is kind of the official agreed upon definition for mass valuation in Estonia, and it goes like this. Land valuation is a market-based valuation process as a result of which an approximate land value is determined for each land unit. It is a mass evaluation, the result of which is a statistical generalization. So this is the what. Why? Why was it done? Well, historically, it has been done periodically. So as you can see in the 90s and then in 2001. But then there was this big gap of 21 years where no valuation was done. And why is this important? Well, the value of land in Estonia is used as a basis, for example, for land taxation, for contracts of use, and for tolerance compensation. And so between this time, the old value was used, and of course, the land value has grown multiple times. The results showed us that in this 21-year period, Estonia as a whole, the land value grew 8.3 times. So yeah, the new valuation was needed. And now in the future, as we can see, the next one, it's going to go in 4-year steps. How we did it? Well, it was done simultaneously. So all land parcels in Estonia, approximately 760,000 of them, were valued at the same time. So it was transactional data for 6 years from 2016 to 30th of June 2022. It was a market-based valuation, so transactional data, and all the data was machine-readable. So no on-site observations were made. So usually when you're valuing land or giving value to land, you have these experts who go on site, they look at the land, they give their expert opinion. But we used only machine-readable data. And it's also important to note that only land was valued. So no buildings were included in the valuation, no growing timber, or no impact of lease contracts. So using expert opinions and using the data we had, we were able to create 5 valuation models. So we have a building right model, which is used in urban region where the market is the most active. So value for land is not based on some characteristics, but rather on the right to build on this land. So we have like city centers and regions like that. Then there's the building land model that is based on residential land sales, agricultural land, forest land, and model for land without active market. So this is land that is used as transportational land, so land that is where roads are built on, also land where bodies of water are. So yeah. These are some characteristics that were included in the analysis. So there are ones you see are crossed out. So at the beginning, there was this long list of variables that we thought had a significant impact on the value. But later, the analysis proved, we did a statistical analysis, that well, most of them did not actually have a significant effect on the value. Now, more specifically, how we used Esri software and how we implemented it in the land valuation project. So, first, location classes. Classifying into location classes was necessary to make distinction in the evaluation methodology, as the market operates differently in different regions. So we have these densely populated areas, cities and suburbia, where the market is more active, where the transactions are done at a much higher prices. How we did it and why we did it? Well, as we can see on the map, there are regions that are darker, red, orange, and these are regions where the market is more active. These are obviously cities, urban centers, and how we did it is we took residential land transactions. We placed this data on maps, and really what it showed us was where transactions were done at a higher price. And I mean, obviously it was not news to us. We already knew that cities like Tallinn, Pärnu, Tartu, sales there are done at a much higher price. But it really showed us the bigger picture, and the experts, like I said before, we only used machine-readable data to make the valuations, to create the valuation models, but experts were included in the process because they helped us creating this table. So we had location classes here, and we had price levels where these transactions in these location classes were made, and we also determined the lowest price level for each location class. So, GIS online web applications. In total, we created 3 web applications: building land, arable land, building rights, and location classes. And these were necessary in the final stage for displaying evaluation results, testing, and conducting quality control. Now, quality control was done by the experts. So, you can give the experts this big table of thousands of rows, but really it doesn't show them. We can make assumptions on it. We can't get any results. But if you give them this kind of map, they can look at it. They see, here prices are higher, here it's lower, and they can help us in making the models more accurate, because those are experts who are every day working in this field, in real estate. They know the market, they know the demand, they know the supply. They can say to us that prices in this region are actually lower, and this helps us to make our models more accurate. And yeah, really it was important. So we had this data, we data analysts had this data, we uploaded it to ArcGIS, and so the experts were able to see the data, they were able to see the changes live. So every day it was an evolving process, every day the data was changing, and so we got better results thanks to the experts and thanks to ArcGIS. Now, it was also used to test results. Here we see transactional data for arable land. So again, we had these transaction points, we put them on the map. Here, the green dots represent model values that were accurate, so they matched the expert opinions. Blue dots are where model value was more than 30% lower, and red dots are where model values were more than 30% higher. Now, data processing. So we had this old soil map, and we had this new improved land improvement map and land improvement system. And the soil map was even older than the first valuation projects. So it was, very old, tens of years old. But we needed a system, we needed a place where we can kind of join those two maps together. So the new land improvement map and the old soil map. And then we got the result, soil fertility map. And this is really important because soil fertility is a significant and important characteristic in determining the value for arable land and forest land. ArcGIS was very important in testing the methodology. So at the beginning there were a lot of ideas, there were a lot of methodologies we can chase after, and so ArcGIS helped us in finding the right one and also excluding the wrong ones. This is an example of a wrong one. We used geostatistical analysis to interpolate arable land transactions. Here again we can see the transaction points, and it was supposed to show us where arable land transactions are done at a higher price. In the end, like I said, it didn't go into action. We didn't use it, and it was because it was deemed not transparent enough and not accurate enough, plus the cleansing of data was not reliable. So we had to exclude this methodology. Here is just another example of using geographic information for visualizing transactions. So this is what we call nearest transactions. Nearest transactions are used in valuation models to set the basis for each unit. So we have location class 3, which is a much more active market. This seems to be some suburbia. So there's a distance between transactions is much smaller. The units are very similar in size and other characteristics. And then there is the location class 8 with not so much active market. The transactions are very over the place, over the map. Sizes are very different. And this is just another way of using this data. The government also created this map application to show evaluation results and calculation process. And like I said, the next valuation is already in less than 2 years. Until this, we explain the previous results, we gather new ideas, we work every day, and we analyze the results and hope that the next valuation project will be better than this one. And I thank you for listening.
Thank you, Hendrik. I was thinking when I was listening to your presentation, in case I decide to relocate from Latvia to Estonia, where should I buy land?
It really depends on what kind of land you want.
To build a house?
To build a house.
Where is the best price performance?
Oh, you want like an investment, you mean?
Yeah.
Okay. I mean, you can't go wrong with Harju County, but I guess the prices there are much higher than the rest of Estonia.
And if I want somewhere on islands?
On islands?
Mm-hmm. Latvia doesn't have islands, so...
I mean, I guess you can get a reasonably priced land in Saaremaa or Hiiumaa.
Okay, we'll take into the mind. So I'm still reminding that you can ask questions in Slido if you have any. But, if we're moving to my questions and the more serious part, what are future plans for Estonian Land Board? You said that you will do the next appraisal in 2026. Have you in mind any other methodology or something else?
Well, right now it's kind of early to tell, because well, the bigger picture for Estonian land board is that in the autumn we will join different agencies together, so it's going to get much more complicated. Our department is gonna triple in size, and first let's just look at what happens there. But speaking in terms of land valuation, yeah, there are some methodologies we have to change. For example, indexing the older sales, and this is, yeah, so the older sales have to be, kind of matched with the current market.
Okay, thank you. I don't see questions in Slido. So thank you again a lot, and
Thank you.